we are given two blocks, block A and block B, which have a mass of 3.5 kg and 2 kg. So they are connected with a light string across a smooth pulley. So at time equal to 0 second, initially the block A is pulled by a force of 30 Newton. So given the coefficient of kinetic frictions between the block A and the table is 0.2, so this will telling you that this surface is rough. So we are going to have friction act on block A. Calculate the accelerations of both blocks. Both blocks is attached together by a string, so they are going to have the same accelerations. Then we are going to calculate the time taken by block B to move up by 1 meter. So class, under the actions of the external force applied, we can predict that the block A are going to move or accelerate leftward, and at the same time block B will going to accelerate upwards. So we are going to calculate the time taken by the block B to move upward by 1 meter. So again, I'm going to follow the problem solving strategy step in order to calculate the accelerations of the system. Alright, so we are going to sketch the FPD. So what force are going to acting on block A beside the external force applied? We can see that this block have mass, so we are going to have weight downwards and also perpendicular to the surface because it's contact with the surface. Then we are going to have the normal force. Then on the right side, it was attached with a string, so along the string we have tension. Beside that, because we predict that the block A is accelerate leftward and the surface of the table is rough, so there will be a friction that parallel to the surface that acting rightward, opposite to the direction of motion. So we are going to have Fk. So this is the forces that are going to act on block A. How about block B? So for block B, so along the string we are going to have the tension. And then for block B, we have mass, so straight downward we have the weight for block B. So block B is hanging freely in the air, so it doesn't contact with any surface, so there will be no normal force, there will be no friction acting on block B. So here will be our FPD for both blocks. So we treat this one as our x-axis and vertically as our this one as our y-axis. Same goes for FPD, the second FPD for block B. This will be our y-axis and here will be our x-axis. Okay, then so after you put your axis, you can see very obviously for block A, the normal force and the weight is lying along the y-axis. The tension and friction force is act along the x-axis. But then the external force, 30 Newton, is at an angle 30 degree. So this one we can resolve it into two perpendicular components, component x and component y. So the x component of the applied force, 30 Newton, will be 30 cos 30, and the component y for the applied force 30 Newton will be 30 sin 30. Okay, so same goes for block B. Tension and weight is lying along y-axis. There will be no forces that we need to resolve. So I have resolved the force 30 Newton. So I might delete this one. Okay. We have already put all the forces along the x directions and also y direction. Then we can start to solve the questions. Fourth step, we are going to write out our Newton's equations to calculate the accelerations. So I put the direction of acceleration predicted in the FPD. So we predict that for block A, it is going to accelerate leftward, and for block B, is going to accelerate upwards. So we write the Newton's equations for block A first. So for block A, since block A is going to accelerate along the x directions. So I focus on all the component of forces along the x directions. So I'm going to have summation of force along the x directions will equal to MA. So refer to the FPD, we can see obviously 30 cos 30 is in the directions of A, so we treat it as positive. But Fk and tension, the directions is opposite to the directions of accelerations, so this one will be negative. So we are going to have 30 cos 30, the force in the directions of accelerations, minus the force that opposite to the directions of accelerations, which is Fk and tension. So minus Fk minus tension equal to Ma. Alright, so Fk is mu Kn, and the value of mu is already given in the questions. Anyhow, we doesn't know about the normal force acting on block A. So in order to solve this question, we need to determine the normal reaction force acting on block A. So the normal reaction force acting on block A is along the y-axis. So we write Newton's equation for y-axis. But for y-axis, there will be no motion. So we are going to apply Newton's first law. Summation force along the y-axis equal to 0. So we are going to have Na plus with 30 sine 30 minus the weight of A that act on opposite direction, which is downward. So weight A equal to 0. So I put in the value. So Na will be, weight, I move it to the right side. So weight is mg. So the mass of block A is 3.5 kg multiplied 9.81. Okay, so minus 30 sine 30. So you might pause the video to do the calculations. So 19.335 Newton. Okay, so once I get the normal force acting on block A, I can put it back into the Newton's second law equations for x directions. So I'm going to have 30 cos 30 minus Fk is mu Kn. So the value of mu is 0.2. So the value of normal force is 19.335. So minus tension equal to the mass of block A is 3.5 times A. Okay, so I solve this one. I'll get 22.11 equal to 3.5 A. Negative T, I move it to the right side, it becomes positive T. Okay, anyhow, I cannot solve the question to determine the accelerations because the tension is unknown. Never mind, we put it as equation 1. Then we try to find another equation in which we have acceleration and tension. Okay, so we can refer to block B. We might refer to block B. So block B is accelerate upward, so we can apply Newton's second law along the y directions. So summation force y equal to Ma for block B. So tension is the force that same direction as A. Weight B is the force that opposite to A. So we are going to have the force in the directions of A, tension, minus the force that opposite to acceleration A, WB, so equal to Ma. So I'll get T minus weight B will be the mass of block B 2 times G 9.81 equal to 2A. Then I rearrange this equation, so I'm going to have 2A minus T equal to 19.62. So this will be my second equations. So boys and girls, we already get two equations. Equation 1 and also equations 2. So you can use the mode. So we can use the mode equations in calculator to solve the equation 1 and equation 2 simultaneously. Then I'm going to get the acceleration will be 0.45 meter per second squared and the tension will be 20.53 Newton. Okay, so we solve question A. Then we proceed to question B. Question B, I want to calculate what is the time taken by block B in order to move upward by 1 meter. So we understood block B are going to move upward, accelerate upwards in a straight line. So we might apply kinematics equations in order to solve this question. So given that we want to find for the time in order for the block to move a distance of 1 meter, and the accelerations is already calculated 0.45 meter per second square, and now we understood that initially the block is not moving, so u is 0. So we can use s equal to ut plus half at squared. So 1 meter, initially u is 0, so this one can be cancelled, half, acceleration is 0.45 t squared. Then solve it, I will get the time taken to travel 1 meter will be 2.1 seconds.